play a game by yourself?
Well, there's no one else to play with. Do you want to play with me?
I'm not very good at it, but can you teach me?
Sure, it's actually a lot like simple physics. So, it's like the concept of the law of conservation of energy, where energy can never be destroyed or created. So, we can take into account Newton's second law, which is force equal to mass times acceleration. So, right now, as the balls are all staying stationary, there's a gravitational force and a normal force acting on it. So that's why the balls are all, energies are being transferred as the balls are being hit.
So you're saying that the greater the force, the greater the acceleration? So force is proportional to acceleration?
Exactly. So F is equal to mass times acceleration. So the harder I hit with the force, the faster the acceleration. And if I was to hit it a lot lightly, the force is lighter, the acceleration.
I get it. So beforehand you said that Newton's law was in play. But according to Newton's first law, all balls are in motion. So shouldn't both balls be in motion right now?
Forever? Well, sure, if we were in space. But we're not in space, so there are different forces that are going to be acting on the balls that's going to eventually make them come to a stop. While we're hitting the balls for the white cue ball, Newton's third law is in place that says that when an object exerts a force on another object, it gets pushed back in the opposite direction equally as hard. So when the white ball hits this ball is also pushed back, and it pushes this ball back as it moves. Here, let me show you so you can understand it better. So I hit this ball, and it's gonna hit that ball, and there's gonna be a force exerted back on this ball, which is eventually gonna slow this ball down. And see how the white ball over here stopped a lot sooner than the purple ball? We also have to factor in friction, because this felted table creates friction that's also acting within the system, that's also taking away, that's the force, the second law, force equal to mass times acceleration. We can account in the force of friction, which is going to be opposing the motion. So the table is going to be exerting a force of friction in the opposite direction of the actual movement of the balls. So again, we see friction happening, which is also adding to the system and making the movement stop. So F, force of friction is equal to the coefficient of friction times normal force. So acceleration is equal to sum of forces minus the frictional force over the mass of the ball, if that's what the cue ball, if that's what we're taking into account.
Jack, are you forgetting something? What about momentum?
Yeah, because look at all the collisions taking place, and it's pretty clear that they're all elastic collisions because they all bounce off of each other, which is going to tell you that there's a conservation of momentum.
But how do you know that it's not, how do you know it's elastic?
Well, because all of them are bouncing off of each other. So, and you know that they're not sticking onto each other, because if they did stick, then they would be inelastic.
Oh yeah, so in this scenario, this would be conservation of momentum, where mass, and they both have the same mass, times the velocity of the first ball plus the velocity of the second ball will give us the momentum.
Exactly. So now that you understand the nature of physics and collisions and forces and everything that's applied into the game of pool, now let's play.